For as long as humans have looked up at the night sky, a single question has lingered in our minds. Are we alone in the universe? Generations of thinkers, dreamers, and scientists have speculated about life beyond Earth. From ancient philosophers imagining countless worlds to modern astronomers searching for signs in the heavens, the quest has endured. Today, this age-old speculation is no longer just a matter of imagination. For the first time, science is edging closer to an answer. The James Webb Space Telescope, the most advanced space observatory ever built, has detected evidence suggesting that life may exist on a planet orbiting our nearest neighboring star system. That world is Proxima Centauri b, an exoplanet only 4.2 light-years away, residing within its star's habitable zone. If confirmed, this discovery would change everything. It would alter how we see ourselves, how we define life, and perhaps even how we plan our future as a species. The power of the James Webb Space Telescope. The James Webb Space Telescope, or JWST, represents one of humanity's greatest scientific achievements. Launched to a stable point nearly a million miles from Earth, Webb operates far from the interference of our planet's atmosphere. Its giant 6.5-meter primary mirror, more than double the size of Hubble's, gathers faint light from the most distant and ancient regions of the cosmos. But Webb is more than just a bigger telescope. It is an observatory designed specifically for infrared astronomy. Infrared light is invisible to human eyes, yet it carries vital information about the universe. It passes through cosmic dust clouds, unveils hidden structures, and reveals the chemistry of planetary atmospheres. This unique capability allows Webb to peer into stellar nurseries, uncover the earliest galaxies, and, most importantly, analyze the delicate atmospheres of faraway worlds. Webb's instruments. Windows into the unknown. To accomplish this, Webb is equipped with an array of precision tools. NIRCam, near-infrared camera, used to capture incredibly sharp images in near-infrared wavelengths. It helps scientists study how galaxies grow and how planets form around stars. NIR-SPEC, near-infrared spectrograph, breaks incoming light into its component wavelengths. This method, called spectroscopy, acts like a cosmic fingerprint scanner, identifying the elements and molecules present in distant atmospheres. MIRI, mid-infrared instrument, extends Webb's sensitivity to longer infrared wavelengths. It is especially important for analyzing cooler objects like exoplanets and for detecting molecules such as carbon dioxide, methane, and water vapor, the essential building blocks for life. Together, these instruments give astronomers a toolkit unlike anything humanity has ever had before. How Webb searches for life. So, how does Webb look for signs of life? The method relies on spectroscopy during planetary transits. When an exoplanet passes in front of its star, a fraction of the starlight filters through the planet's atmosphere. That light carries subtle imprints, tiny absorption lines that reveal what gases are present. By carefully analyzing this filtered light, Webb can detect oxygen, methane, water vapor, and even more complex organic molecules. These are known as biosignatures, chemical hints that could point toward living processes. Even more fascinating is Webb's ability to measure the balance of these gases. On Earth, for instance, oxygen and methane exist together because they are constantly replenished by life. Without biology, these gases would not remain stable for long. Detecting such imbalances elsewhere could be a strong sign of alien life. Proxima Centauri b, our closest candidate among all the exoplanets Webb is studying. Proxima Centauri b holds a special place. Orbiting the red dwarf star Proxima Centauri, it lies in the so-called habitable zone, the region where liquid water could exist on its surface. Recent observations have hinted at intriguing possibilities: traces of water vapor, signs of carbon-based molecules, and atmospheric structures that resemble those of a potentially habitable world. Scientists are cautious, stressing that more data is needed to confirm these signals, but the excitement is undeniable. If life truly exists on Proxima b, it would mean that our nearest stellar neighbor harbors biology. Such a discovery would suggest that life in the universe is not rare or unique, but perhaps widespread. The confirmation of life beyond Earth would not simply be another entry in a scientific journal. It would mark one of the greatest turning points in human history, a moment when everything we thought we knew about our uniqueness in the cosmos would have to be reconsidered. For thousands of years, Earth has been seen as the rare jewel of creation, the only known home for biology, intelligence, and consciousness. But if Webb has indeed found signs of life on Proxima Centauri b, then life is not a fragile accident confined to one world. It may be a common thread woven into the very fabric of the universe. Philosophically, such a revelation would be staggering. It would mean that humanity is not the solitary voice in a silent cosmic wilderness but part of a far larger symphony of life. Ancient questions would resurface with new urgency. What does it mean to be human if we are not alone? Is life inevitable wherever conditions allow? And could intelligence arise again and again, across countless worlds? Scientifically, the implications would be just as profound. The discovery of extraterrestrial life would transform biology into an interplanetary science. Researchers would need to compare Earth's biochemistry with that of other worlds, asking whether life always follows carbon-based chemistry or whether it can take unfamiliar, exotic forms. Entire disciplines could be born: comparative evolution, interstellar ecology, and universal biology. And the questions would only grow bolder. Does life always begin with microbes? Does it naturally progress toward complexity? Or is intelligence a rare accident, unique to Earth? Each answer would not only illuminate the story of life elsewhere, but also reveal more about our own origins. Technologically, the confirmation of alien life would ignite a new age of exploration. For centuries, humanity has looked outward with curiosity, but the discovery of living worlds would give us purpose. It could inspire investments in new propulsion systems, perhaps nuclear or fusion-driven spacecraft capable of interstellar travel. Interstellar probes, once confined to science fiction, might become real projects, designed to reach Proxima Centauri within the next few centuries. The dream of becoming an interstellar civilization would shift from imagination to long-term strategy. Humanity's role in the cosmos would no longer be about survival on one fragile planet, but about connection, discovery, and expansion among the stars. A new cosmic perspective. Yet even if Webb never directly confirms life, its contributions are still reshaping how we understand existence. Its breathtaking views of distant galaxies, star clusters, and nebulae are more than just beautiful, they are windows into cosmic history. By observing light that has traveled for billions of years, Webb is showing us galaxies as they appeared shortly after the Big Bang. These discoveries are rewriting the timeline of cosmic evolution, revealing that galaxies formed earlier, faster, and with greater complexity than scientists once believed. Each new dataset sparks wonder but also deepens the mystery. What unknown forces shaped the earliest galaxies? Why do some stars form so quickly while others linger in darkness? How many Earth-like worlds might be hidden in the vast expanse of the Milky Way? And the most haunting question of all, if life exists on Proxima Centauri b, how many more living worlds might lie scattered among the stars? The telescope's discoveries remind us that our galaxy alone contains hundreds of billions of stars, many with planets. If even a small fraction of those planets harbor life, then the universe could be teeming with biology. Life, rather than being rare, might be the universe's greatest story. The journey ahead, the mission of the James Webb Space Telescope, is far from over. In fact, it has only just begun. Over the coming years, Webb will gather mountains of data, refining our understanding of exoplanets, tracing the life cycles of stars, and uncovering structures of the universe invisible until now. Its findings will ripple across generations of scientists. Students who today marvel at Webb's first images may one day build the spacecraft that follow up on its discoveries. Future astronomers might look back at Webb as the telescope that gave humanity its first true glimpse of life beyond Earth. But perhaps Webb's greatest contribution will not be measured in raw data, but in perspective. By looking across billions of light years and peering into planetary atmospheres, Webb has shown us something profound. The universe is not empty, it is alive with possibility. It is reminding us that we are part of a vast, interconnected story that began long before humans walked the Earth and will continue long after. Each new discovery Webb delivers is not just about distant stars and galaxies. It is about us, about who we are, where we came from, and where we might go. Conclusion. The James Webb Space Telescope is not simply an instrument. It is a time machine, a microscope, and a cosmic storyteller. It has already changed our understanding of the universe, and it is poised to change our understanding of ourselves. With its unmatched ability to study the faintest galaxies and the atmospheres of distant worlds, Webb is bringing us closer than ever to answering humanity's most enduring question: are we alone? Whether it ultimately confirms life on Proxima Centauri b or reveals other habitable worlds yet to be discovered, Webb's mission is a turning point. It is the bridge between imagination and evidence, between wonder and knowledge. And as its golden mirrors continue to capture light from the farthest reaches of space, humanity stands at the threshold of a new era, an era where we may finally realize that Earth is not the only cradle of life, but one of many sparks scattered across the cosmos.